This presentation will be on a mathematical analysis of weight loss, weight stability, and the body weight plateau. To begin with, I need to convince you first that we're extremely terrible at determining how much intake we're actually taking in. And I'm going to use some studies to convince you this, but without that being convinced, the rest of this kind of falls apart. So I really going to spend some time on that part of it. And other convincing data that we have is the difference between what we call in-residence studies. Those are studies that are held inside in confinement, and everything's supervised and measured. So we really know what the subjects are doing, versus free living studies, and what this information tells us. Next, I will tell you about this very interesting individual in the field of obesity research, Klaus Westerter, who measures himself every day. In fact, in his paper, he doesn't say it's himself, but it's himself. And his data was very interesting, and it tells us maybe why our appetite might change, even though we may not recognize that there is a change. Then I'm a mathematician, so I'm going to show you some insight that we can gain into using mathematical models, but I will not show you any equations. I'm just going to show you some interesting things that we can derive from those mathematical models. And finally, I don't want to have a message where it shows that you can't do anything about your weight. There is something called the National Diet Registry, where you can sign up for if you've lost weight and kept it off for a period of 1 year. So there are successful weight loss and weight loss maintainers, and they have some characteristics that are very similar among these individuals. And so I'm going to show you some really neat things about that study and leave you with that. So self-reported intake. In the past, researchers did recognize that people have a difficult time determining how much they eat. And it wasn't just an issue of lying, it's just also an issue of remembering. Today we do have issues with what we call self-reporting or underreporting due to social bias. You might not want to tell someone that you had the donut. In the past though, because of this recognition that we don't have this measured exactly, there were incredible studies run that were I call confined. So we have people in residence, all the food is given to them, everything is measured, they're supervised 24/7. One of the most famous of these studies is the Minnesota starvation experiment, which you see some pictures here, where 32 objective dissenters to World War II were, instead of going to jail, were offered the opportunity to be part of this study. And Ansel Keys ran this study. Ansel Keys is actually known for using BMI for the first time to characterize obesity and body weight, body fat. In this particular study, where it's going to come up again, these individuals were housed at the University of Minnesota, and they were kept there for a period of 24 weeks in a case of semi-starvation. And the whole point of this study was to understand how individuals who are undergoing a famine or food deprivation could be refed in the best possible way. And the object of this was that after World War II was over, they could go into countries, the U.S. could go into countries and refeed populations. So how does self-reported intake work? Well, it's exactly what you would think. You're asking people how much or what they ate. There's different methods of how to do that, and there's quite a few papers on these methods. They actually are correlated to each other, but that doesn't mean that they're measuring the thing you want them to measure. So I want to distinguish between the two. One is called the Food Frequency Questionnaire, which is used by the CDC, and it's actually a pretty long questionnaire. I had my students fill it out for one of my classes, and you are trying to remember the types of foods that you ate, so types of soups and how often you ate them. The other type is what we call a food record, a 3-day dietary record, where you're keeping a food log. You're going to actually see one of those 3-day dietary records. They're pretty interesting looking, but you're just keeping a log of everything you ate for a 3-day period. And finally, there's something called 24-hour recall, where individuals are called, usually by telephone, and asked to remember everything they ate over a 24-hour period. In the early 1980s, Dale Schuller from the University of Wisconsin-Madison used doubly labeled water for the first time in humans. So there's issues with confining people in a study because they may not be behaving the way they would behave in a free living environment outside in the world. And so asking people was the only way to really find out what people were doing outside of the outside of a confined setting until Dale Schuller developed the doubly labeled water method, which is a chemical isotope, DLW for short, that you ingest. And from the urine, they can determine how much carbon dioxide has been netted. And from that, you can determine how much oxygen has been consumed. And think of oxygen as important for lighting a fire. So it's an important component to burning. And therefore, from oxygen consumption in humans, we can tell how much energy they've burned. 1 liter of oxygen consumed is equal to 5 calories burned. And from that, I can get how much they expended per day. So you really, this is called doubly labeled water for energy expenditure, as you see in the title of his paper up here. But most people are at least for short time weight stable. That means their intake must equal their expenditures. And if their intake equals their expenditures, the doubly labeled water method can give us an approximate, pretty decent approximation to how much they are taking in per day. Once this was done, once the doubly labeled water method was in place, there were a series of studies looking at the validity of self-report. So one of these studies was a study in the New England Journal of Medicine by Steve Heimsfield, and Dale Schuller also ran a number of these studies. And consistently, individuals underreport how much they're eating per day, and they overreport their activity per day. And Steve Heimsfield's study in the New England Journal of Medicine was particularly interesting because it was a group of individuals who he called them diet resistant. So he has some nice names for people. And what they were was they were individuals that said they didn't eat anything, yet they didn't understand why they were classified with obesity. He found out that they were self-reporting about 500 calories a day of consumption, and what they actually were consuming was around the 3,000, 4,000 calorie range. So it's pretty interesting to look at that data, and I really recommend looking at that paper because it's a very nicely done study. Unfortunately, despite all this evidence, self-report is still used today, predominantly today, for a number of reasons. One of those reasons is that you cannot confine people easily today under we have really good institutional review board requirements. So you have to have a pretty good reason to confine individuals. It's expensive to confine individuals. So you're not able to, you have to justify to the NIH if you're applying for a grant why you're doing the study and how it's going to contribute. And you can still only take in small numbers of people in short numbers of days. So people still continue to rely on self-report because it's the cheapest way to reach a vast number of people. The CDC, in fact, collects self-report, costs a lot of money. Actually, it's not cheap because you need someone to actually conduct these surveys. These surveys, like the food frequency questionnaire, is not easy. It took us a while to fill these things out. And unfortunately, scientific conclusions are made from those measurements. In a study by the CDC, they reported that energy intake had decreased among the US adults, yet body weight has increased. By the first law of thermodynamics, that is not possible. So we had written a rebuttal letter to that article, doing some mathematics and showing that this actually was implausible, and that we went through the history of Dale Schuller's doubly labeled water method and what it tells us. And we advocated that self-report based estimates should not be used as a basis for scientific conclusions. And since that time, we've definitely come across this again and again, and we still say that it does tell you some things. It tells you what someone believes they're eating or what they want you to know they're eating, but it doesn't give you that measurement quality that you would get in a physics lab. If I haven't convinced you yet, this is one of my favorite pictures. This is a image of um, a new device developed by Edward Sazonov, and it's a chewing and swallowing sensor that sits on your throat. Um, I did tell him that he could make this into a diamond and women would wear it, but this is not something that is cheap to make, but it's cheaper than WLabeled Water. And so Edward Sazonov's an engineer, and he's developed a couple of these devices. One sits behind the ear, it's less obtrusive, and it detects chewing. But what we can gather from this is we can look at, it won't give us the total intake, but what it will give us is eating habits. And so one of my favorite pictures that he shows us is this one. So this is a 3-day dietary, a part of a 3-day dietary record. And you see the individuals logged what they've eaten at each particular time point that they ate. And they say at 8:30 they ate popcorn, 6:30 they have dinner, so forth. This is data from the chewing and swallowing sensor. And what you get here is the eating episodes line up and match the blue, which is the chewing and swallowing. So number 2 is matched, number 3 is matched, the timing is matched, number 4 is matched, number 5 is matched, but here you have nonstop chewing and swallowing after about 8:30. Now I did ask Edward, did you ask that participant what they were eating? Were they chewing gum or swallowing water? And he said, yes, he definitely asked, and they just couldn't remember. I've thought about this a lot, and you know, people are quick to say, investigators are quick to say that people might be lying. This woman had no reason to lie. She was wearing the sensor. She knows that there's going to be chewing and swallowing data on there, so there's no reason to lie. She's not deceiving anybody. My take on this is that around this time in the evening, well, I'm asleep, but most of the time, this time in the evening, I'm pretty busy. I'm not filling out any, if something gets filled out, it's probably going to get grease on it. I'm in the kitchen, I'm signing homework papers, I'm doing all kinds of stuff. And my guess is that she probably filled this out after the fact and she really doesn't remember. And that's the problem with these food records. They seem so easy to do, but sitting down every time you eat and writing and keeping a log is hard. Think of all the times you've eaten over the last few days. Today we're going to eat here. Is everybody going to pull out a sheet of paper and start writing down what they ate? It's really tough to do. Or you went out to dinner for Mother's Day. You're going to go out for lunch for Mother's Day. You're going to bring a sheet of paper with you. You might fill it out after the fact, and you might forget some things. Okay, so let's move to in residence versus free living studies. This is some work that is under review right now from a study that George Bray ran that's more recent. And not too many people can do an in residence study these days. Well, but George Bray is definitely the master of this. So this was published in JAMA, and it was a study run at the Pennington Biomedical Research Center in their metabolic ward. So individuals went through a period where they called it a run-in period, where their intake was adjusted for their body weight. So this was the adjustment period right here. And then over here, in this run-in period, you see that individuals are titrated to meals. So they were provided to them, and there's very little fluctuation in those body weights, about 1 kilogram of fluctuation in those body weights. Keep that in mind because it tells you a kilogram's about 2 pounds, 2.2 pounds. So there's not much fluctuation in that body weight, and that really tells us kind of what weight stability should look like, plus or minus 1 kilogram. And that's what this paper is about, actually. We wanted to know what weight stability really was, and the only way you can really find that is in a study like George Bray's. I wanted to show you this data. It was so compelling, and actually it was something Leanne Redmond, one of my collaborators, said to me. They had done a similar study to George Bray's. George Bray's was a overfeeding study, and his curves looked like something out of calculus textbook. Leanne Redmond was involved in another study where it was a free living version of George Bray's study, and in that study, those curves were everywhere. They were wiggling up and down. And I said, look how different these two curves look. She said, of course, one is in residence. and one is not. It's obvious. Like, is that obvious? Let's look at Minnesota starvation. That was an in-residence weight loss study. You see these curves going straight down. It's like something out of a calculus textbook. You don't see much, you don't see any wiggling, really. You don't see that. This is a free living study. This is an individual who is overfed. This is not George Bray's study. This is actually this is George Bray's study. This is overfeeding study, I'm sorry. And you see that if you look at the amplitude of these wiggles, it's about 1 kilogram, not much different than the data you saw on the run-in period. And so this is blown up, the y-axis is blown up, so we can actually look at these amplitudes. So there is wiggling around on a daily basis. And this is an overfeeding study, so they were overfed. Why do you see some wiggling here and you didn't see it in the Minnesota starvation? Because this is George Bray and these are daily weights. What you were seeing before there was weekly weights. So this is much more, you're seeing more the daily variation. So we should expect to see about 1 kilogram plus or minus in daily variation of body weights. And that could come from changes in water, so small changes that are natural for the body. This is from the Calorie study, which was also conducted at Pennington Biomedical. The Calorie study was one of the most tightly controlled free living studies there were. WLabeled Water was conducted. Body composition was measured with the best equipment. They had a friend of mine who is a psychologist who is in charge of adherence. That means he keeps people on task. What you see here is the amplitudes of these bumps are about 2 kilograms. And this is just one participant. But you get the idea that there's some fluctuation that's going on that cannot be attributed to just simply body weights changing. We see a difference in free living. And this was a tightly controlled one. There were lots of researchers involved in this, lots of contact with participants. So think about that when you're trying to diet and you say, well, it's not going to happen to me. I'm not going to be one of those people. These people wanted to lose weight and they were part of this study and they had a lot of support actually that wouldn't be given to you in some place like Jenny Craig or Weight Watchers. So you see that you're going to see probably more than this, more than the 2 kilograms that we saw in this participant. All right, Klaus Westerterp, very interesting colleague of mine. There's something funny about working in this area. You naturally start to weigh yourself every day. One day we were sitting around a table and somebody asked the question that dare not be asked among us, and that is, what is your BMI? And one of the researchers said, well, I keep my BMI right at 25, which is the cutoff for overweight. And I thought that was pretty funny because all of us do. We measure ourselves every day and make sure that we stay on target. Klaus Westerterp takes us to another level. He has measured himself for 25 years now, I think, at least over 15. I know he's been measuring himself. And every once in a while, he shows us plots of this data. Over the 15-year period, it's a perfectly horizontal line. So his body weight really doesn't change. Now, he's one of us. And so he had come and told me once, if you want to stay the same weight, you must eat the same foods every day, the same meals every single day. And then you'll stay the same weight. He did not quite stay the same weight. What you see here is 2 curves. These curves here, the black circles, represent his body weight, and the the black circles represent the temperature outside, and the white circles represent his body weight. So you see his, I had this backward, but this represents his body weight, the black circles, and the white circles represent the temperature. And when the temperature goes up, his body weight goes down. And you see about a 2 kilogram fluctuation, just like that free living participant. When the temperature goes down, his body weight goes up. And you can say, well, maybe that's Christmas right here in December. But over here, it's past that time, and you see his body weight is still up, and then it goes back down. Over here, you see a similar sort of thing with body weight and temperature. And what he pointed out is that temperature influences your appetite. This is Klaus Westerter. This is someone who told me I should eat the same food every day. This is someone who flies around the world for conferences with the same scale to collect his body weights. He's meticulous, and yet he could not keep his body weights perfectly in a line. And so this kind of tells us that, and he knows what he's eating. In some ways, all of us know what we're doing because we see so much data. And yet, what he's able to gather from this is his appetite changed. And that might not be controllable like we think. Here's another image of 1997, 98, and 99 data, body weight plotted with temperature. And you see over here down to here, it's a nice little regression line, a nice pattern that you see it's trending down the higher the temperature gets. So again, giving evidence, and this is 3 years of data. He has daily weights actually, and those 3 years of data indicate a tight relationship with temperature. So I'm just giving you one image of where if we can't self-report our intake, or we can't watch our intake to the level that we think we can, and outside temperature influences someone as solid as Klaus Westerter, then we're probably not in control of our intake the way we think we are. The other piece of this is that I know that sleep is also associated with appetite, melatonin levels. So there's things in our daily rhythms that control our appetite, influence our appetite, and we may not have the control we think we have. So what do math models tell us? Well, one of the things, again, so with all this stuff behind us, one of the things that comes up a lot in our studies is that people plateau early. And they say this plateau occurs because something in their body has changed, their metabolism has slowed. So I explored this idea in a thermodynamic model that was validated. So we checked it against actual data and showed that it did really well. And we call this a thermodynamic model. It's not a statistical model where I'm fitting data. It's a model where I'm using the first law of thermodynamics. And once I have that model in place and it's been tested, what I did is I said, okay, what if I start to decrease my metabolism by percentages? And what you see is that in both males and females, the time to plateau, which is just over a year, is the same, even if your expenditures are reduced by 5% or 10%. You lose less weight, but the time to plateau is still the same at the same spot. So it's probably unlikely that your metabolism has slowed and caused you to plateau early. What's more likely is that it's what Klaus Westerter was saying, that it's an intermittent loss of adherence, that we are not every day eating the same foods. So when we derive these mathematical models, we assume that you're eating the same amount every day. And so on this particular weight loss, this is what the calorie study should have happened to that participant if they had stuck to their intake, prescribed intake, like glue. They were locked on. Actually, what happened was the solid curve, and I developed a model that I call it an adherence model, where I put a stochastic element in it. So it's every day I wake up, I roll a die, and I decide, am I going to adhere today or not? And I can put a percentage in there. Sometimes I am, or sometimes I'm not, and it's going to be random. Think about it. Someone shows up at your house randomly, and you have dinner together. So those things, there is a random element to it. What you see is, although it's not a point by point, I can exhibit a curve that looks like those free living curves that you see in reality. What happens over time? Well, over time, you plateau around 52 weeks, as we've seen in the other picture. But here you see that the plateau occurs much earlier, around 10 to 20 weeks, 12 weeks, which is about 3 months, between 3 and 6 months, you start to see what they call the 6-month plateau. And that has to do with not being adherent. So this is just pulling the adherence from the other models and stretching it out over time. All right, don't despair. People have lost weight and kept it off. So my friend Jim Hill runs a registry where people can sign up, and he's been doing this for a very long time. And it is also self-report, which I've dissed quite a bit here. But we can learn something from people who've been successful. Just keep in mind that this should not be used as numbers, exact numbers to make scientific conclusions off of. But they can be used as overall guidance. So you can sign up for the registry if you've lost 30 pounds or more and have kept it off longer than a year. What have they learned? 80 people who've signed up are women and 20% are men. Most of the time, recruitment in these studies, or even for bariatric surgery, most of the subjects are women. And they give you some average demographics of the people that have signed up for the study. On average, most people have lost, on average, people have lost 66 pounds and kept it off for approximately 6 years. But there's a wide range. And he's given these ranges. Some lost it quickly, some lost it slowly. And it feels like when you read the data, there's more studies that they have associated with this database. Some people lose it in a variety of different ways. They lost it on their own, they went on particular diets, some went on Atkins, some went on Weight Watchers. It doesn't seem to matter what kind. Some people went to a formalized program, about half. 98% modified their food intake. So only 2% in the database lost it with exercise. That's really important because one of the questions we always get in the clinic is, can I just burn this all off? Probably not. So there's habits. Some of them I do myself. I've lost 70 pounds and have kept it off, and I'm one of these obesity researchers that get kind of crazy after a while. I exercise every day. I don't watch any TV. I weigh myself every day. I don't really eat breakfast. So 78% eat breakfast every day, but I can tell you why someone might have to eat breakfast. When you've lost a lot of weight, you're always hungry. And when you wake up in the morning, you're very hungry. And if you go, the longer you stay hungry like that, the more likely you are to fall off. And so putting something in your stomach keeps you from going and binging somewhere. So you always have that propensity to binge. I don't eat breakfast because in my schedule, I tend to be at home in the evening and have the likelihood of eating more at night. So when I'm back with the kids. And so I've readjusted my schedule so I don't eat breakfast and I keep my calories, but I always think about keeping my calories down. So with that, I'd like to give my acknowledgements. This is just a short list. I work with a lot of people and they've been very generous sharing data and involving me in their studies. And this is just a short list of some of the people that I work with. I'm lucky to work with Klaus Westerterp, he's one of my favorite investigators to work with.